The battlefield in Ukraine has seen a quiet revolution. Swarms of plywood kamikazes buzzing beyond Russian lines. Armored columns are grinded to a halt, not under the thunder of jet engines or the arc of pricey missiles, but beneath the unassuming hum of wooden drones. These loitering munitions, made from simple plywood yet guided by cutting-edge AI, are funded and supplied by Germany, and they have begun to reshape the cost calculus and tactics of modern warfare. When Russia invaded Ukraine in February 2022, Germany launched a major support effort. By late 2024, it had provided about $49 billion in bilateral aid. This included Patriot air defense batteries, Leopard 2 and Leopard 1A5 tanks, Iris-T missile systems, Jeopard anti-aircraft guns, and hundreds of thousands of artillery rounds. Yet one of the most effective contributions has been a surprisingly low-tech solution: plywood-framed loitering munitions that Ukraine can build, modify, and replace all at once. Germany's strategic rationale is straightforward. Advanced weapons require complex logistics chains, secure airfields, and specialized crews. They also risk capture or destruction in large, high-value batches. In contrast, a wooden drone can roll off a simple production line, resilience factories erected in barns or industrial parks, be assembled by a handful of technicians, and launched from improvised clearings near the front. At a unit cost measured in mere thousands of dollars, these drones are attritable by design. Lose one, replace 10. The program's emphasis is on volume and redundancy, forcing Russian air defenses to choose between conserving expensive interceptor missiles or allowing some drones through to their targets. The flagship model of this approach is the HF-1, produced by the German defense tech startup Helsing. Structurally, the HF-1 is as unassuming as it is effective. A plywood fuselage, for electric rotors arranged in an X-wing configuration, and a 3D printed nose cone housing sensors and guidance electronics. It can loiter for up to 60 minutes, engage targets 27 to 31 miles from launch, and carries a warhead capable of disabling light to medium armor, radar arrays, and supply stockpiles. Guidance is hybrid. Primary navigation uses GPS, while terminal guidance relies on onboard AI vision systems that identify and lock onto designated target profiles. If the data link is jammed or disrupted, the HF-1 can autonomously seek its last known waypoint and execute its terminal dive based on visual cues alone. Operators report successful strikes on parked armored vehicles and radar sites at distances of 30 miles behind Russian front lines, locations formerly considered sanctuaries. Plywood, the HF-1's signature material, confers unique advantages. Its low dielectric constant reduces radar cross-section more than aluminum or carbon composites would. Special adhesives and hydrophobic coatings keep moisture absorption in check, preserving aerodynamic shape and structural rigidity across temperature and humidity extremes. Moreover, the wooden frame acts as a thermal insulator, dampening the drone's infrared signature and complicating attempts to acquire it with heat-seeking sensors. These characteristics force adversaries to employ more sensitive and costlier detection systems or to saturate airspace with anti-aircraft fire, both of which dilute their defensive resources. Production numbers illustrate the program's scale. An initial batch of 600 HF-1s was delivered to Ukraine in January 2025. By mid-April, an additional 150 units were in theater. As of May 2025, over 1,050 units have arrived, with 4,000 more on contract under German financing. The coalition's financial framework extends beyond this initial tranche. In March 2025, the outgoing Scholz administration unlocked a $3.4 billion supplemental package and earmarked $9.32 billion from 2026 through 2029 for continued drone production alongside conventional systems. This steady stream of funding ensures that German plywood drone factories remain at full tilt. The next evolution in Finland's, and now Ukraine's, arsenal is the HX-2. Unveiled in December 2024, Germany's approach has inspired allied contributions. In March 2025, the United Kingdom leveraged its international fund for Ukraine to procure Andural's Altius loitering munitions, the 600M and 700M variants. The Altius 600M carries up to 6.6 pounds of modular payload, explosive, sensor, or electronic warfare options, can loiter up to 4 hours, and boasts a range of up to 276 miles. Its larger sibling, The Altius 700M carries a 33-pound warhead roughly comparable to an AGM-114 Hellfire missile and sustains a 75-minute on-station time. Launched from ground vehicles, aircraft, or portable launchers, these drones extend Ukraine's deep strike reach and complement the HF series by prioritizing payload over cost per unit. Domestic Ukrainian industry has not sat idle. In 2024, local firms produced approximately 2.2 million drones across all categories: reconnaissance, loitering, and FPV attack, eclipsing Russia's 1.5 million annual output. Among these are plywood-framed knockoffs of Russia's Molniya FPV drone, reverse-engineered from captured examples. The Ukrainian variant replicates the Molniya's 5-foot wingspan, 22-pound all-up weight, and pneumatic launch mechanism, while adding AI-assisted video targeting and reinforced wing spars. These DIY units operate at ranges up to 18 miles and speeds of 50 miles per hour, filling the low-end attrition role and preserving higher-end assets for priority missions. Russia's own Molniya family underscores the parallel evolution of wooden drones. Fielded in late 2022, the Molniya is designed to be assembled in 10 backpack-sized sections, carried by 3 soldiers, and launched via a simple pneumatic catapult. It loiters for up to 40 minutes and delivers a one-way strike against infantry concentrations, light vehicles, or static positions. But lacking advanced AI, network coordination, or low observability coatings, Molniyas struggle to penetrate Ukraine's electronic warfare defenses and are increasingly countered by simple directional jamming and point-defense automatic weapons. The strategic impact of these wooden munitions lies in the shifting cost exchange dynamic. A typical surface-to-air missile costs between $50,000 and $150,000. A plywood drone with a warhead might cost $2,000 to $5,000. By saturating contested airspace with dozens of expendable drones, Ukraine compels Russia either to expend expensive interceptors or to accept occasional penetration that can disable critical logistics nodes, radar installations, or command elements. Over time, this attrition by swarm depletes both material stocks and defender morale, gradually tipping operational initiative to the attacker. Beyond direct combat, plywood drones influence operational planning and force posture. Russian units must now allocate air defense assets not only to frontline positions but also to rear areas previously considered safe. Logistic hubs, ammunition dumps, and fuel depots require new protective measures. Meanwhile, Ukrainian commanders can integrate drone swarm tactics with artillery barrages and electronic warfare operations to create multi-domain, synchronized assaults that exploit gaps in Russian defenses.